So 2.5, absolute value, equations and inequalities. Absolute values, right? And we've talked about this already. An absolute value is just asking how far away a value is from zero. The problem is, now we're going to see x's inside the absolute value. Now, the same property applies though. It's saying, instead of let me rephrase that, how far away a value is from zero, it's asking what values, right, of x would make it true. So if we said, for example, on this one, right, absolute value of x equals, I don't know, 7, okay? You know, we're going to see an example like this. Hold on to that one. Let's review just real quickly some of that absolute value stuff. So evaluate the expression, the absolute value of 43. Well, again, this would be asking how far away 43 is from 0. And 43 is still 43 away from 0. Okay, so it's a distance. We only talk about distances in the positive. So even like this one, where it's the absolute value of negative 1,524, and I really hope that it doesn't matter how big the number is, or if it's a fraction or decimal, the principle still applies. Well, how far away is it from 0? It's still 1,524 away from 0. All right, so some students get kind of mixed up, especially when they see this negative thing. Is it an opposite thing? It's not. It's not an opposite thing. It's a positive thing because it's a distance. And I got to tell you guys, if you start talking about distances and the negatives, people might look at you weird, and you may never see them or talk to them again, okay? Like if you said, I live negative 15 miles east of Salt Lake, you know, they'd be like, oh, what the crap is that? And then, well, maybe someday he'll make a good politician. I'm just waiting for this to come up. But in any case, when we see this as an equation, though, it's really asking what values are a certain distance away from 0, like we saw before, right? So it says, for absolute value of x equals a, if a is positive, then we solve x equals a, and also x equals negative a. I'm going to expand on that a little bit more. If the x inside of that were 0, then, well, there's only one number 0 away from 0, and that is 0. But this last one right here, if a is negative, then the absolute value of that it just has no solutions. And again, that may not make complete sense, but I hope we can kind of determine why it is that way here in just a second. So, and I have a way to work these out, which I hope ends up being very easy for us. But this first one right here, this one, if a is positive, then solve x equals a and x equals negative a. And we see that on this next example, right, where it was, dang it, absolute value of 7, no, absolute value of x, right, equals 7. Okay, now this is really asking what numbers are 7 away from 0. Well, that's when I say, well, we're going to split this up, and we're going to say, well, x would then equal 7. And when I'm writing this in red here, that means that the red 7 would go inside the absolute value, right? I'd be replacing that x. Just like we've done, what was it, 2.1, I think, right? Maybe it was 1.1. Where we evaluate these, right, you're replacing the letters with numbers. But also, if x were to equal negative 7, again, that would be on the inside of that absolute value. Well, negative 7 is 7 away from 0. So there's two values that are 7 away from 0, okay? Now that third one, it's saying the absolute value of x. And by the way, these are going to expand very soon. Like, you won't just see an x inside these absolute values. You're going to see bigger expressions in there, which may include some distribution, fractions, decimals. You just never know, right? But if we said the absolute value of x equals negative 3, for example, well, what value is negative 3 away from 0? And you could say negative 3, that's true, but again, it's a distance, right? So since it is a distance, we never actually talk about distances in terms of negatives, okay? So I would recommend, well, that's what you're going to have to do, is if it's that That's never, you guys. Sorry, that came out weird. But that negative sign means that there's no value, there's no absolute value that you could ever get that's negative. Now that doesn't include if negatives are on the outside of the absolute value. Then it changes. But for now, if you don't see that negative sign right there, it's automatically DNE, does not exist, no solutions, whatever it says on the homework. Now this last one here, this one, it's just the same as if it were to say the absolute value of something equals something else. It essentially becomes something like this. Okay, so even if we put absolute values around the 7, it's not going to change how we do those. Okay, you're still going to split it up where one of the values is positive, one of them is negative. So yeah, again, just going back to this one, right? We already know that x, it could equal 7, but if you replace that x with negative 7, it would still be true. All right, again, big number, small number, decimal, fraction, it doesn't matter. Well, I mean, maybe there's less calculation, but would look at this thing and would say, what values are 624 away from 0? Well, if we said x was 624, that would give us originally a true statement in the original equation. But if I also said that x was equal to negative 624, it would still give me a true statement. So yeah, and again on the homework you guys are going to be listing this as 624 comma negative 624. All right, now again, like I said, we're going to see more expanded expressions on the inside of those absolute values. No problem, okay? We still are going to split this up into two separate equations, just like we did before. It's just it was just a regular x, right? So this is, if I can get x minus 9, that's the inside of that absolute value. If I could get it to equal 2, the original equation would be a true statement. But also, if I could get x minus 9 to be negative 2, inside of the absolute value, it would still give me a true statement, okay? And seems like we've seen this before. Maybe I'm thinking of my other class, but yeah, we're just going to add 9 to both sides of both equations, actually. Kind of speeds it up a little bit. And then we get x equals 11, but also x equals 7, right? And again, going back to x's being solutions, it needs to make the original equation true. That's what a solution to an equation is, right? So if we said, well, 11 minus 9, the absolute value of that, does it equal 2? It does, because 11 minus 9 is 2. The absolute value of 2 is 2. But if I replace the x with 7 now, 7 minus 9 is negative 2, but remember, you still have to take that absolute value of that negative 2, which is still 2. Yeah, and that's a good question. From what I remember in the homework as well, it doesn't matter if it's least to greatest that I remember. So the negative 2 thing, and I maybe if I had finished that, it would have made more sense. But right, with the negative 2, it gave us this x is 7. So I got that in the equation. And now when I solve this, 7 minus 9 is negative 2. That's the same negative 2 that we were trying to get from the beginning. Because I know the absolute value of negative 2 is 2, which it is 2, which makes it true. So this negative 2 is actually on the inside of that absolute value. So, I mean, like you said, the first one is, I think it's pretty straightforward, right? Like if we can get 2, then it's automatically equal to 2. So, but the absolute value, again, it goes back to the question it really puts forth is, what value is 2 away from 0? Well, 2 is 2 away from 0, and then that's where the other part of it, the negative 2, comes from, right there. Yeah, so, well, yeah, give us more space. I do want that space. All right, so again, I'm going to split it up into two separate equations on this, right? And I got 4x plus 2, and that's the inside of the absolute value. If I could get it to equal 6, it'll produce a true statement or a true equation there. But if I can get 4x plus 2 to equal negative 6, it also will produce a true statement. in the original equation. So right here, right, again, it's the same thing for both. It doesn't really matter. We're going to subtract 2 from both sides of both equations. So that zeroes out our 2's there. We'll drop the 4x. 4x equals 4 on the left, and on the right, 4x equals negative 8. Oh, that worked out pretty good. And then, yeah, you guessed it, divide both sides by 4, so x equals 1 on the left, and on the right, we'll still divide both sides by 4, but now x equals negative 2. And again, you can check, right? So up here in the, I'm not going to show the word just because I don't have the space, but 4 times 1 is 4 plus 2 is 6. Absolute value of 6 is 6. That's true. That checks this one off. If I replace the x with negative 2, so 4 times negative 2 is negative 8, which we kind of expected here in purple. Negative 8 plus 2 is negative 6, which is what we were trying to make it become. The absolute value of negative 6 is 6. So that also is true. All right, here's absolute value with a fraction in it, okay? Now, you do need to be careful just because of things. That's all I'm going to say for now. And I know that's not very specific, but I would not multiply by 3 until I've split this up into the 2 separate equations, all right? So we are going to have the 2 separate equations, but I'm going to keep the divide by 3 in the original. You just got to be careful. If there was more to it, then sometimes it can throw us off, especially once we start dealing with inequalities, which is coming very soon. So again, if I can get the inside to equal 1, which is what I have here on the left, then it will produce a true statement originally. If I can replace the x with, or what's inside with negative 1, then it would also give me a true statement. So here we go. We're just going to solve this like we would usually, right? A little bit more space, actually. So yeah, multiply both sides by 3 for both equations. So that's going to cancel out our 3's, which is what we want. So now we got x plus 12. That didn't work out very well. Equals 3 on the left. And also x plus 12 equals negative 3 on the right. So we'll solve this one by just getting rid of 12 on both sides of both equations. So on the left we get x equals, that zeroes out. 3 minus 12 is negative 9. And here on the right, subtract 12 still. But now x equals negative 15. Oh, negative. I didn't like how that negative came out. That's good. That's okay. All right, so, let's just check. We'll go through it real quick. So negative 9 plus 12 is 3. Again, it's kind of what we expected in purple there. 3 divided by 3 is 1. That's the red one. Absolute value 1 is 1. That's true. Now if we replace the x with the orange negative 15 there, negative 15 plus 12 is negative 3. Again, we did expect that. Negative 3 divided by 3 is the red negative 1, which is what we wanted. The absolute value of negative 1 is 1. So both of those answers produce true statements in the original equation. All right, if you come across something like this, then we're really looking at manipulating these equations, just like we did in, what was it, 1.8 or 9 or something like that. So what I want to do is I want to isolate the absolute value of x. In other words, it would be like those literal equations where it's like, hey, solve for absolute value of x, okay? So I can't separate these until what I have left is just absolute value of x equals something. Okay, then after that, then we can separate it into the 2 separate equations, okay? Because even at this point, some students would look at this and they'd say, it's an absolute value on the left and a negative on the right, and we already found that that's impossible. Well, it could be possible. It depends on what the absolute value of x needs to equal. So if it was needing to equal a negative, then it would no longer be true. But this one's going to come out okay for us. Because if I were to isolate the x, I would need to get rid of the 6 here. So I'm going to zero that out. And that leaves me with negative 4 times the absolute value of x equals negative 12. And here you guys see that we're going to divide both sides by negative 4. Which then gives us, right, that becomes a phantom 1. The absolute value of x equals, it's just 3. So yeah, we can solve this one with the 2 equations, right? And it's not even that difficult at that point. X can equal 3, but X could also equal -3. That's true. So again, just going back, right, the absolute values, it should punch out a 3 for us, whether the X is positive or negative. So absolute value of 3 is 3. -4 times 3 is -12, like we expected. -12 plus 6 is -6. So that produces a true statement. So it is a solution. But what about -3? Absolute value of -3 is 3, and we already ran through that process. So both of these, again, make the original equation a true statement. I'm going to work the same thing on this one. Right? We got to isolate the X, or the absolute value of X on this. So I'm going to zero out that -35, right? I'm going to add 35 here to both sides. So that's going to give us, I guess, 8, positive 8 on the right. Now it's a negative absolute value of X, right? We got to keep that subtraction as the sign of the absolute value. And there's really a phantom 1 right there, so I'm going to divide both sides by -1. I know some of you guys would just say, well, I'm going to move the negative to the right side. That's fine. It's the same thing. So now I get 1 right there. It's a phantom 1. The absolute value of X now equals -8. And this, at this point, this is where we're like, oh, that's jacked up. You can't have an absolute value that is a negative. That can never happen. So yeah, on this one we say does not exist. There's no solution for this one, which I like. I like these ones because, I mean, I wouldn't say it's half the work, but it's not as much work as the other ones. All right, what about this one? Same idea, okay? So if you guys are getting tired of it, hopefully it's just kind of clicking for you guys at least. So yeah, add 7 to both sides, right? That zeroes this out. So we got 2 times the absolute value of 5x minus 3 equals 26. And yeah, we'll get rid of that 2. Oh, yeah, this is a good point right here. In years past, when the test was on paper, some students would look at this thing and then be like, oh my goodness, look what I can do. I can distribute. Do not distribute, okay? It can cause problems. So please do not distribute. The absolute, it's almost like it's out of order from the order of operations. You got to do the multiplication after you look at the parentheses on this one, which are the absolute values, okay? So do not distribute on that. Now we'll divide both sides by 2, right, to make that 13 there. So the absolute value of 5x minus 3 needs to equal 13. And yeah, at this point we'll split this up into 2 separate equations. We got 5x minus 3. If it could equal 13, it would be true. But if 5x minus 3 were equal to negative 13, also true. And we got a couple 2-steppers on this, right? So this would be a 3. So add 3 to both sides on both equations. So here on the right, 5x equals negative 10. Oh, that was a poor 0. Oh, 0 out, that's fine. And we got 5x equals 16 on the left. So finally, to solve these ones, I'm going to give myself more space first. Yeah, we'll divide both sides of both equations by 5. So here on the left, x equals, I'm just going to keep this as an improper fraction, 16/5. And on the right, x will equal negative 2. Well, just, running back to the original equation, right? 5 times 16/5 is 16 minus 3 is 13. Right, that's kind of what we're looking for out of those absolute values. And 13 times 2 is 26. Negative 7 plus 26 is, 19. But what, yeah, go. So yeah, I'll finish this up with the x is negative 2, right? So negative 2 times 5 is negative 10 minus 3 is negative 13, which again is kind of what we're expecting green there. The absolute value of negative 13 is 13, and we already ran through that process, so it checks off. Okay, well, you guys try this one out, okay? We'll give you guys a minute. All right, it feels like it's been a minute to me. Maybe it's because I'm kind of sitting here in silence. But in any case, if you're still working on this thing, you're working way too hard, you guys. Let me show you. All right. So again, before you even look at the inside of that absolute value, please solve for the absolute value. So just zero out that 19 right there. So, well, minus 19. So now we got 13 times some absolute value. And I'm not writing that on purpose, but it's negative 26 there. And then divide both sides by 13. And then we get an absolute value that equals negative 2. Well, no matter what's on the inside of this absolute value, this could never happen. So it's a does not exist one. Be careful, okay? Just if you see something really big like that, I always get a little suspicious. Again, it's not supposed to be one of those gotcha moments, but sometimes I feel like I can hear the math people laughing at us, you know what I'm saying? So don't be tricked, okay? Isolate the absolute value first to see if you even need to do anything on the inside. So if you're looking for a dead giveaway and it starts out this way, because there's a lot of stuff to distract you from what the purpose of this problem is, right? It's like, holy smokes, I got to distribute the 5, and then I got to combine like terms, and then I got to split this thing up. But if we can focus just for a second and just kind of step back from the problem, kind of analyze it at first, we should. And another thing I should have mentioned about suspicion, right, is if you ever see it equal a negative, even if those numbers were there, right? If we let me see if I can bring that back here. This stuff, right? The 19 plus 13. If it were there, then it'd be like just that it equals a negative 7. We should be suspicious, but it's not a dead giveaway until we take that garbage away, and then we look at something like this. So all of this stuff on the inside really is just meant to distract you. If you ever get an absolute value that equals a negative, you're done. All right. Well, I'm not feeling as much anger as I have in my past classes, so you guys, it's pretty good. Now, you could think about this for a long time, why, or what kind of values this two absolute values would produce. But the truth is that you could say, you know what, I'm going to split this one into, well, that was kind of big. And then you could figure out those two answers. But then you could also turn around and say, you know what, I'm going to split the other one up in two as well. Now, one thing we have discussed already is that, if you make the right side negative and positive, then you're good. But if you were to change it and make the left side negative and positive, you're still good. And that's all this does. It's a redundancy. You don't need to do it 4 separate times because the two answers are going to be the same for both. And we'll confirm that at the end of this one, even if it's just kind of quick because of time purposes. So I always just split up the one on the left just because for the most part we're going to see absolute values on the left side of the equal sign. So again, I write that absolute value as is, negative 4x plus 5. But then it equals the opposite. I take that back. First off, it's just the regular other absolute value. Okay, so it's just straight up 3x plus 5. Now, that's the other one that I was talking about. Negative 4x plus 5. That stays. But then I change the signs of those. So it's like taking the negative of it. Okay, so it's negative 3x now minus 5. And these two answers would be the same two answers as if we were to take the 3x plus 5 and split that up. Okay? So, yeah, let's go ahead and solve these. It is a good question. If there was a negative in front of this, straight up, no solutions. Because the negative in front is going to make the whole thing negative, and we can never get an absolute value that equals a negative. Now, on the other hand, if this 3x was negative, what you said is correct. Instead of showing negative 3x here, it would be positive 3x minus 5. On that second part, all we do is switch the signs. That's it. Now, some people would say, well, I like to see it as, let me write that in there. I like to see it as 3x plus 5 in parentheses and then negative. Okay, it's the same thing. And then you distribute the 1, and then you still get what we have in red right there. So it is a negative 1 being distributed, essentially. But I think most students catch on a little bit faster if we say, just change the signs. That's all we're doing, right? Because what I want on the inside of that negative 4x plus 5 is both the positive and the negative part. of the answer there. So solving these two, right? So yeah, I got to subtract 5 from both sides. Now it's not the same on the right, so I'm going to separate those. All right, so yeah, subtracting 5 from both sides, you know, we get zeros out from both sides. And then we got a negative 4x. You know what, actually, I take that back. I'm going to do this in one step, just, again, for the sake of time. So you guys like the x's on the left, so I'm going to subtract the 3x from both sides. Which makes this negative 7x equals, yeah, look, both of those zeroed out, so it does equal 0. And to solve this, we'll divide both sides by negative 7. And we get x equals 0. All right, so one of the x values that would make this true is 0, and we can check that right now before we look at the other one. Negative 4 times 0 plus 5 is 5. Absolute value of 5 is 5. Well, 3 times 0 is 0 plus 5 is 5. Absolute value of 5 is 5. Bam, it works. Now that's just x is 0. But let's look at the other side, right? So again, we'll say the x's go on the left and the numbers go on the right. So I'll subtract 5 from both sides, while simultaneously adding 3x to both sides. All right, so that zeroes out here and here. Negative 4x plus 3x is negative 1x equals negative 10. And to finish this one off, we'll divide both sides by negative 1. And x equals 10. So let's check this one. Let's see how this goes. All right. So negative 4 times 10 is negative 40 plus 5 is negative 35. And the absolute value of negative 35 is 35. Well, 3 times 10 over here on the right is 30 plus 5 is 35. The absolute value of which is still 35. So we ended up with 35 equals 35. It checks off. And, you know, I'll write this one in like, you know, you have to do it on the homework. X equals 0 and 10. Just put a comma between those two. But now we're going to look at all the absolute value inequalities, right? But do keep in mind that all the same rules for solving inequalities still apply. So really all that means that if you ever divide both sides by a negative or multiply both sides of the equation by a negative, then it's going to flip the inequality, okay? Now, let's see, what does it say? What values of x would make the following statements true and why? You may want to use the number lines. Well, if you were just to think about this, it says to use the number line. You know, I'll show that to you anyways, but whatever. There's 0, there's 5, and there's negative 5. That's as much as I need. If this were an equation, right, you'd say, well, you know, we're gonna say x equals 5 and x equals negative 5, right? If it were an equation, and then you'd say, yeah, we got values of negative 5 and 5, and I'm going to keep those open because it's not actually equal in the inequality. But then we got to consider, well, we know negative 5 and 5 wouldn't make it true, but it's also where we transition from equality to inequality, right? So we may think about, well, what values of x would make it true? Well, 0 would make it true. Like, if I took the absolute value of 0, it would make it true. If I made it 1, it would be true, and 2, and 3, and 4, and everything in between, right? But then we have the negative 5 as well, and so we may think, in addition to that, are there any negative values that would make it true? Well, yeah, negative 1, the absolute value of negative 1 is still less than 5, and same with the absolute value of negative 2, and negative 3, and negative 4. All of those would be true, which means that it's all the values in between these two. All right, almost like an and statement that we would have been used to, right? Now, what this ends up being is it's kind of like a reflection. At 0, everything to the right going to 5, it just kind of reflects and goes the other direction. I don't really know that that's super applicable, but it may help you to kind of make sense of this all. But if we ignore this number line garbage and we said, you know, it's a split between the two, that's great because you end up with two separate inequalities. You'd have the original, whoops, that's a little big. You'd have the original x is just less than 5, that would be great. But remember, with the negative thing, it flips the inequality, so x could also be greater than negative 5, which also means that it has to be an and statement between these two. Now, of course, for a compound inequality, you'd say x is less than 5, but greater than -5, like this. And this is, I guess, the more formal version of it. You got the two circles on the graph on the sides and then everything in between. So you'd fill that line between. And then if it did ask for the inequality, you'd probably put in something like this one right here. Now the interval for this one, we'll do it real quick, but as far to the left, I'm looking at the orange now. It goes as far to the left as -5 where it stops. It's not included though, because it's an open circle. Then it goes as far to the right as 5, still an open circle, so it's still a regular parentheses there. And that would be the interval notation. So the homework may ask for 1, it may ask for all 3. I actually forget, so I apologize. So if I want to know what values of x make this inequality true, let's zoom in on that so it's not as messy. I know that everything to the left of 5 would make that true, but because it's an absolute value, it kind of it has a limit on it, right? So it kind of has to do with this mirror image thing, where we say, you know, it's this, but it's flipped, it's mirrored, and so everything to the right of this -5 would be true. Yeah, so to expand on this, right, if we were to say, you know what, let's look at values to the left of that -5, well, we know, for example, if I said that x was -6 right here, right, -6, well then it would be the absolute value of 6 is less than 5, which isn't true because, well, 6 is not, it's not less than 5. So it means that everything to the left of the -5 would be false. So we have to look at all the values that are to the right of -5, which would produce this inequality right here. If you said, well, it goes from, let me zoom back out there, sorry. If I said this includes from -4 to 4, and it's true, like 4 is included in the solution set and -4. The problem is it doesn't include the decimals and fractions between, which also would make it true, right? If I said x was 4 even negative, doesn't matter, -4.999, I'll put one more 9, okay? If I said x was equal to this -4.9999, it would still be true. And that's where the graph visually shows that not only does it include the 4 like you're saying, but it also includes everything to the left of -4 and then to the right of, well, +4 right here. Because we do need to include all those decimals and fractions. Now, if you're looking for strict rules, okay, practically this is just algorithm, right? If you ever get the absolute value equals a, right, we know it's just the two values. That's the first part of this section. The second part deals with these second two. If you see that, again, it doesn't matter if it's x right here. It could be 3x plus 5 equals 19, or plus 19x, whatever. You could have parentheses and distribution in there. It's just saying the absolute value of something. If you get the absolute value of something is less than a number, then you end up with an and statement, just like we did in that last example, which hopefully we'll expand on. Now this one's showing not equal to parts, which is why we get the regular parentheses here. If it was equal, then it would just be square bracket on both of these, okay? Now if it were to eat the absolute value, like this one, then you end up with an or statement, which means that the values of x that would make this true are everything to the left of the -a and everything to the right of the +a. Now, we're going to see these expanded, of course. So remember, this is still very abstract, which means that, you know, we're going to be splitting this up into two parts, right? We'd say x is greater than a, but also x is less than -a, which is why it becomes an or statement. Now, if that really sucked, don't worry about it. I don't really use that diagram when I'm solving these or graphing them or finding my interval for these, okay? So like this one is just an application of the rule, and there's usually a question like this on the homework. If you see an absolute value is less than something, is it going to produce the and statement or the or statement? Well, it's not eating the absolute value, so it's going to be the and statement, okay? And again, if it were to eat the absolute value, it would be the or statement. That's it. All right, here we go. This is our first non-just x1. So let's says it wants our answerable interval notation, so we're going to do the graph on this one as well, right? So, and this is a straight absolute value compared with 9. So yeah, let's split this thing up, guys. We got 5x minus 8. If it can be greater than or equal to 9, that'd be awesome. And I don't care about the OR statement right now. It is an OR statement, but I don't care. The graph should reveal if it is or is not. But then if 5x minus 8, if it were less than or equal to negative 9, still true. And again, since I'm dealing with the negative 9 now, it flips the inequality. Okay, so yeah, solving both these, we'll add the 8 to both sides like this. So again, 5x is greater than or equal to 17 there. Add 8 to both sides on this one. So now I get 5x is less than or equal to negative 1. And divide both sides by 5. So this first one, x is greater than or equal to 17/5. And the one on the right, divide by 5. And it's still dividing by positive, guys. So it still remains x is less than or equal to negative 1/5. Now it's an OR statement. All right, so we have this, and again, I'm going to put the OR statement between that, just because it is the inequality portion of this. But let's look at the graph now. Okay, so I got 0, I got negative 1/5 to the left, and I got 17/5 to the right. Again, I'm not worried about how proportional this is. But I'm going to start with the green one. At 17/5, it's a closed circle because it's equal to the 17/5. It's eating the x, so it goes to the right. Now the orange one, at negative 1/5, it's still equal to the 1/5. So I get a closed circle there. It's not eating the x, so this one is going to go to the left. So we can see pretty clearly that this, or hopefully it's clear, that it's an OR statement. Excuse me. But let's write out the interval. The orange line goes as far to the left as negative infinity. It stops at negative 1/5. And yeah, it's not included, so I got a regular parenthesis there. And we'll unite this with the green one, starting at 17/5, which is, oh, I put a parenthesis on that one. It should have been a bracket. I apologize. Yeah, square bracket, because it is included, right? It would be a regular parentheses if it was an open circle. So the 17/5 as well, it's included, so a square bracket there, and that green line is going to go all the way to infinity. And that is our interval notation. Question 2. So let's say that, you know, like I put an OR in between the two inequalities earlier. We should know that it's an OR statement by the time we see the graph like this. Okay, because as soon as we see it going in both directions, then it usually, almost always, only in very rare cases is it not an OR statement. And the only case that would happen is if we were comparing it with a negative. In other words, the 9 up there would have been negative. So if you solve these and you end up with something like this, it is going to be an OR statement. Other than that, the only way we can tell is by kind of going back to that one slide where it says if it eats the absolute value, then it's automatically an OR statement. Now, if it did not eat the absolute value, then it would have been an AND statement. Here's an absolute value. I know you guys have been looking at this for the break, and probably loved it, because now some of you guys, we kind of get in the habit of just being like, I'm going to split this thing up, and I'm going to make it equal to negative 9, and then I'm going to switch the sign over here. But hopefully that, just by doing that part of it, threw you off, because we're comparing this to the negative. It's a negative 9, right? Well, from this absolute value, you'll always get a positive, and positives are always greater than negatives, which means this is, well, it's all the real numbers. So let me think. It just wants the interval notation. The graph would just span the entire graph, and to show that it is all numbers, or all real numbers, right? We say it goes from negative infinity to infinity. Bam, done. So do be cognizant of where or what you're comparing, right? I mean, we have that negative 9, and while math tends to be kind of a mindless, robotic process, you do need to do some analysis here and realize that, yeah, an absolute value is always greater than a negative. So this is all real numbers. It's this giant span of intervals. Yeah, so in order for this to be DNE, right, does not exist, no solutions. The absolute value has to be less than the negative, right? Right? It doesn't matter what's inside here, x, 3x plus 25, doesn't matter. The absolute value, once it's less than a negative, that can never happen because, again, out of that absolute value, you'll always get a positive, and positives are never less than, or equal to, for that matter, negatives. They're never, this can never happen. Question, so if we went back to the first part of this section, it was the same section, and it kind of feels like it was so long ago, right? If we said an absolute value is equal to any negative, like negative 9, then it was also D and E, because that would be like saying that out of that absolute value you're going to get a negative. You can't. It just can't happen. Now we're going to spend more time on this section, even though I know we've spent quite a bit, because the next section hopefully we can do kind of quick. All right, so same thing with this one. It says the graph the solution. We'll give the integral notation as well. That's fine. But again, it's the same idea as though it were an equation. We just need to isolate the x. So, I'm sorry, the absolute value rather. So yeah, we're still going to add 7 to both sides. And that zeroes that out. So we got 11. Absolute value of x is less than or equal to 55. Oh, that's going to work out real nice. Divide both sides by 11. And then the absolute value of x is less than or equal to 5. Well, with this, and hopefully we realize, well, maybe not, we haven't had a lot of experience with this, but this is going to be an and statement because it's not eating the absolute value. And again, if you were to analyze this, you'd say, well, it's not, if this 5 was negative, then it would be one of those D and E situations, but that's a little off topic there. So, right, I'm going to say, well, x is less than or equal to 5, and that would be true. But if x were greater than or equal to negative 5, that also would be true. Okay, and yeah, you can put the and statement in between, but that's why they kind of showed it like that on that slide and say, well, just put it like a compound inequality where it's just one giant inequality like this. Because it is the same thing. It's just, again, it becomes an and statement on that. But it wanted the graph on this one, so let's go ahead and put this on. So here's our number line. I'll put 0 in the middle, negative 5 here on the left, and positive 5 on the right. I'm going to get closed circles for both. Yeah, the positive 5 on this, it just stays the same, right? Because it was already less than or equal to, so the positive stays less than or equal to. And so when I change the sign on the 5, the negative 5, to make it negative 5, then I flip that inequality into now, instead of it being less than, now it's a greater than symbol. Yeah, for this and statement right here, right, like I wrote this one here, it's just like this. Now when I compare the x with negative 5, it just has to eat the x, right? That's what this one's saying. It's saying eat the x. That's Shalagat, it's real hungry. So it has to eat the x when I put it in this compound inequality like this as well. But yeah, let's go ahead and continue then. So right, with the x being compared to 5, it's not eating the x, so that line goes to the right. Oh, I put that the wrong direction. I meant the left. It's not eating the x, so it goes to the left. And then the negative 5, it's eating the x, so this one goes to the right. But again, it's kind of like the negative 5 and the 5 are kind of a barrier right there. And so we end up with just the line between the two. Now that's the graph. We need the interval notation as well. So I see that the orange line, it goes all the way to negative 5. It's included because it's a closed circle. It's not my best drawing there, but it's a drawing. And then it follows all the way to the right to 5, which also is a closed circle. So it also has that square bracket. All right, yeah, what about this one? Well, same idea, it doesn't really change. We'll isolate the x. We're solving for that absolute value, right? So subtract 9 from both sides here. And that zeroes that out. That's good. We'll drop the 4 times the absolute value of x. And I'm just separating those just so we can tell the difference. Otherwise, it kind of looks like the absolute values are 1s, just the way that I'm writing it. Then we'll divide both sides by 4. And again, we're dividing by a positive, so it doesn't actually flip. It does not flip the inequality. And 4 divided by 4 is 1. So now that we have this, let's go ahead and split this up into the two separate inequalities here. And this one is eating the absolute value, so it ends up being an or statement. But again, it should show that it's an or statement. Just like that last one, we should have understood that it was an and statement because whether we used the compound inequality or not, it intersected. So we got x is greater than or equal to 1. And now when I compare x to negative 1, I got to flip that inequality. So this is our or statement, and that brings us then to the graph. I just want a little bit more space. All right, here's my graph. So negative 1 and 1, there's 0, there's negative 1, there's 1. And at 1, we get a closed circle because it's equal to 1. It's eating the x, so it goes to the right. And at negative 1, still closed circle. And both of them will be closed automatically because the original inequality was equal to. But this one does not eat the x, so this one goes to the left. Right? And it is an or statement, so you could put your u down there for the integral notation if you'd like. But that orange line to the left goes all the way to negative infinity. It stops at negative 1. It's included, so I get a square bracket. And then it starts up, right, we're uniting it at 1, which is included, so we get a square bracket there. And this goes all the way to infinity. There's our interval. Now I got to tell you guys, I'm getting a slight sense of hopelessness on this. And again, I hope that I hope that you guys kind of feel a little bit more empowerment as you try more of these. And even if you guys got to make mistakes on those, okay? So make your mistakes, redo those problems on the homework, and get the practice you need to really understand. I mean, even if you don't understand what's going on, at least hopefully you can understand how to solve these, right? Like on this one, if I were to solve these, I'd split it up into 2. Well, I was hoping someone would catch me on this one. You're not going to split it up into 2. That's correct. Yeah, we got this. Again, don't get so robotic that you're just splitting this up into 2. You see that it's eating the negative and not the absolute value. That can never happen, right? And if you did, you'd say that a positive is less than or equal to a negative. Never. It can never happen. It just does not exist. No solution is 1. I like that so much because a lot of students, they look at the fraction right here, right? And they're like, I quit. Well, if you would have just, went a little bit further, hopefully you would have seen that it's being compared to a negative right there.